Hi Sumit, good evening.
Yeah, hi KG.
Hi Sumit, nice meeting you again.
Yeah, again. Hi, how are you doing?
Yeah, doing great. Thank you.
Yeah,
Thanks for organizing this.
yeah. So I think we can start or we should wait 2 minutes.
Hi Sumit, hi sir.
Hi Anshika, you can call me KG. Yeah.
Okay, hi KG.
Nice meeting you, Anshika.
I already told her to call KG. Okay.
Okay, so good evening everyone. I, Anshika Kashyap, on behalf of QuCode team, I'm delighted to welcome you all to this special session of the Learning Quantum Computing series. Today we are honored to have with us Mr. Karthiganesh today, also known as KG, an accomplished quantum computing architect, Power BI consultant, and professor of practice. Mr. Durai comes with a rich and diverse background spanning data science, AI, and quantum technologies. He has held key positions at leading organizations such as Dell Technologies and currently contributes to cutting edge work at Boston Psi QuantumG Research Labs and Mete Meenakshi Institute of Technology. So we are truly excited to learn from your experiences and insights, sir. We'll now move into, over to you, sir.
Thank you. Thanks a lot, Anshika. Thanks Sumit for organizing this session.
Yes, sir.
And I think it started 7 days back, right?
Yeah, like 25th, somewhere
And
around 25th
there
or
are
end of, yeah.
45 members joined already. I believe all of you started your journey doing some assignments, exploring, and there are a lot of chat GPT.
People are
Nothing
doing
wrong
it,
in
yeah.
it. If you
Mhm.
start learning from ChatGPT, nothing wrong in it. It's okay. And one thing I will tell you, in this process, it is like blind leading blind. And then what about those who have real vision? They don't have time for leading us. So those who have meaning that good experience in building the solution, don't have time to deliver this kind of sessions for larger audience. We cannot complain them because there is a lot of pressure on those scientists, innovators, to build the next generation quantum computers. At the time, it is very difficult for them to find time and come to the um, field and deliver a session on quantum computing, that is to at the layman level or entry level. They are ready to work with you when you upskill yourself such that you can communicate with them. So don't worry if you are start learning from ChatGPT or any YouTube video or discussing with some friends. I'm not mentioning the books and all, because learning from book is a different experience. Learning from ChatGPT or YouTube is a different experience, and particularly learning from a hardbound book, that is a pleasant experience. But most of us may not have time to turn a hardbound book and sit down, find a time sitting in the proper lighting room and read a hardbound book. You know, all of you, right? I'm not sure how many of you out of 53, how many of you fan of reading a hardbound book. But most of the quantum subjects, I have hardbound books. That I am fan of reading hardbound books. So why I'm starting with the hardbound book, reading hardbound book. That is an important first step to start building your quantum computing career. Quantum computing career is not something like classical career, because in classical career it is a matured technology. There are well defined process, well defined theorems, well defined solutions. You cannot get misguided. If you choose Gen AI, you cannot get misguided. You will go properly with the Gen AI tools knowledge path. And if you decided to become a data visualization, Power BI, Tableau, those kind of things only will go there. But when it comes to quantum computing, there are a lot of things are there. So obviously you may get misguided and confused. That is the reason why my first suggestion, start reading hardbound books. One or two books, Mike and Ike, the quantum computation, quantum information by Michael Isaac Chong and Michael Nielsen. That book. You must have that book, hardbound book, kind of Bible. Then, for understanding the mathematical side, you should read Chris Bernhardt book, Quantum Computing for Everyone. These two books are you must have a hardbound. Then, if you are studying for quantum machine learning, Maria Schuld book and Peter Wittek book, you cannot skip these books. And in the current stage, Srinjay Ganguly book. Right? Srinjay Ganguly wrote an amazing book on Python, implementing quantum computing solution using Python, and Q Sharp also. It is amazing book. So these are all the various books. So that is the first step. And I have PPT. I will share my screen and then show the PPT just to start with, and then you will start asking questions. Feel free to drive this 1 hour session by your questions. So this is my recommended learning path. Always identify the domain. Quantum programming, even though there is a quantum computing programming, it is not computer science alone. It is pure interdisciplinary. That is the challenge with the quantum computing career. If you are decided to pursue a quantum computing career, mentally you should become a domain expert, a subject matter expert, a little bit of physicist, and more combination of mathematics than computer programming. And because of this, quantum computing career offers opportunities for core engineers compared to computer science and information technology career freshers. And most of the quantum computing organization, you can find mechanical, electrical engineers compared to computer science engineers. The main reason is that the domain problem. The domain is the crux of your quantum computing solution. So why it is very difficult, or why domain is required? The other day I was delivering a podcast with Paradwaj. That time also I shared with him why we need domain. Before explaining the domain, anyone have any idea or why we need domain? You can paste it in the chat window or unmute yourself and then ask. I will include that in the explanation. Domain or what is called the field where the subject matter expertise. It is very important. I will tell you. Classical systems are used to solve any level of problem. For example, if you take a finance domain. In finance domain, we will use Excel sheets to prepare the basic financial report, monthly report, or simple creditor report, or ledger, or trial balance, or profit and loss balance sheet. Those kind of basic accounts too. We will use the Excel or Python or MATLAB code to perform some research level problems in finance, like Monte Carlo simulation, optimization, and portfolio optimization, scheduling, shortest path problems, or max cut problems. Those kind of optimization problem also we can do using Excel for finance. But when it comes to quantum, it will always attack the research level solution or research level problem in that domain. I will type here because most of the problem what we are using in quantum computing are R&D level program. So who will do R&D? Those who are expert in that particular domain, they only do the R&D, correct? So when you're talking to the middle level manager or entry level professional in that particular domain, they cannot realize the necessity for quantum computer. For example, you are enthusiastic, you are going to one of the Fortune 500 company, and there is a supply chain operation, supply chain management or operations team. They are handling the supply chain management. You are going to them and telling them, hey, I learned quantum computing programming. Can I do some programming for you? They know, no, we don't need quantum computer, because they are not operating at the research level problem. They are operating on day-to-day operations. They don't need quantum computer. But if you do someone who is doing PhD in finance, maybe PhD in supply chain management, or PhD in operation research, or PhD in logistics, in specialized particular focused problem, they will tell, yeah, I need, because my classical system is not able to process the request. That is where all problem starts with the quantum computing career. I know out there, because of the National Quantum Mission introduction, and then the recent announcement in Amravati, Hyderabad, Amravati, Andhra Pradesh, for building the quantum village. And there are a lot of hype over quantum computing, from Google willow climbing septillion tasks in few seconds, and Microsoft climbing topological qubit. There are a lot of news. Is indeed quantum computing is the most happening area now in 2025. We are trying, okay, this is something less crowded, no competition, let us try. That may be few views. For some people, they have the kick, because they're very difficult, no one can pursue. Let us focus on the showcase our knowledge or our expertise or intelligence. There are many reasons, but the underlying fact is that quantum computers are attacking the research level problem in every domain. That is where the freshers and beginners are struggling to understand why we need quantum computer. If you don't know why we need quantum computer, what will you do? You will try to build a quantum computing solution for bubble sort also. You understand what I'm telling? Using a quantum computer for bubble sort is a crime, because quantum computer can do unstructured research. And trying to build something very trivial application using quantum computer, no, not necessary. I have seen, since there is a quantum machine learning, I have seen some of the problems what a classical machine learning is more than enough. Then why we need quantum computing? You understood, right? I ready to answer question, then I will move, because the whole session go with only one slide.
Yeah, so one question we have received, that is like, what are the opportunities in quantum computing in graduation?
Any
Somebody asked
specialization?
by Dipanshu.
Which specialization? Computer science or electrical or ECE, or which
Okay,
STEM?
just somebody please mention it. Then, yeah, another one is calculation and differential equations not needed? Pradiksha asked this question. Yeah.
Okay, first I will answer the first question for undergrad. For
Undergrad, she wanted to say about physics, like she mentioned.
oh, okay. Physics people are most welcome into quantum computing domain. Indeed, I in my organization, I have 2 masters in physics and 1 mechanical engineer, and 2 computer science interns. This is what my team as of now. Earlier, I had 3 physicists, 2 2 mechanical engineer, and 2 computer science. That computer science always I will keep it for freshers. But when it comes to some experienced work, I prefer a master's in physics. The reason is that the physics students or physics graduates, particularly masters graduates, undergrad may not be cope up with all concepts, but masters are really good. So they can come to domain, and they can go to mathematics, and they can come cross also. That is one advantage with the physics people. In As I told you, if there is 3 people or multiple people, and there is physics, I will give preference to physics. Hope that answered the question. And second question, mathematics, differential equation, and what is the other one? Oh, it is not in the message here.
Yeah, I have created Q&A, so by that I can see
Oh,
the
okay, okay.
questions.
I will open the Q&A. Yeah. I
Is it
have.
visible now?
Now
No?
I opened. Okay.
Okay, so then
So there
is
is one.
calculation and differential equation not needed? Somebody asked.
I'm checking that question.
Yeah, this Pradiksha
There's a
asked the
difference.
question.
No. It is very much important to understand domain problem as well as quantum computing approach. The only challenge is that, our only addition is that you have to include complex numbers rather than real numbers. That is the change, or that is the paradigm shift. When it comes to quantum computing, we have calculus, we have differential equation, we have linear algebra, everything we have, but they are operating on complex numbers rather than real numbers. Hope that helps a lot.
Right.
And there is one more question. You, what path can see a student follow? Since you said that only core students, Siddharth, I want to make correction. It is, domain is very important, then physics, then mathematics, then programming. So there are many solutions. All program must be done by computer science students only. You understood, right? So computer science students are very crucial, because I in my team I always keep two software engineers. So the physics and mathematicians and domain expert will be domain expert or our client. Physicists and mathematicians are building the solution, meaning that they will give the mathematical model or physical explanation to the domain, but the actual implementation will be computer science students. What I expect from my software, the software engineer, they should understand the mathematical model for the problem and little bit physics and little bit domain, such that they will able to build, or they will be able to understand the request. So computer science are crucial. Computer science students, if they are, when they jump into quantum computing, they should ready to learn the necessary level of mathematics and physics and domain. Maybe 8,000 feet level of the mathematical concepts, 7,000 feet level physics, then another 8,000 feet level for domain. Make, hope that answered your question, Siddharth. And
Oh, this one. Could you please send us those book, Learning
ah,
Hard Quantum Computing? So we will share that, like because a lot of other questions are pending. I will read for you.
okay,
Do we need to masters in mathematical complications to show great results in quantum? So you already answered that math part.
we need master in mathematical not necessary. So here I will tell you, as I told you, my team consists of four group of people. One is domain, usually they are client. I will not have expert for domain in my team, because very costly to maintain researchers in particular domain. So usually my clients are my domain expert. I have physicist to understand the problem explained by the domain, and I have mathematician. This mathematician should be a PhD level mathematician. But the software engineer, he or she need not to master mathematical concept. He or she should know the level of what to say, the complex numbers and the linear algebra and these operations, how they are used to um, formulate the problem, statement of problem, into quantum space. That is what, that level they know, that is enough. Hope that makes sense. How QC works in R&D of material science, it is a deeper thing, because material science simulation, you, since you are, I think the question related because you are in that domain,
Okay.
obviously you know material science, the material simulations, they are deep problem in computer, the intersection of computational chemistry and material, right? And if you're trying to build any model, for example, CCD or heart tree, or there is one more thing called mm, there are one more model. It's not, I'm not able to recall that one. Those chemistry model, and then the reaction, all those things, those are all computationally complex, and then they fall into NP hard problem because they are exponential. Their complexity grows exponential. So this any complexity, computing complexity, which is O of 2 power n, sorry, n power 2, or any exponential representation, those are class of the problem and in material science which we need quantum computer. And if you need more information, please connect with me. If you ask Sumit, Sumit can share my number with you. I can connect you with a professor who is working in material science and integrating or trying to utilize quantum computing for their material science problems. Because material science simulation is the ideal candidate for quantum computing. Why? That is natural simulation. If you try to use classical system, we have to approximate the number and we lose accuracy in that behavior. That is why material scientists are predominantly trying to use quantum computers for their simulation. Bala Bhaskar asked one question. Please share for the application of quantum computing in health and informatics. Health and informatics, I would like to go to biotechnology.
Yeah,
Why?
like drugs discovery, these things.
Under biotechnology, it is a drug discovery, protein prediction, protein folding, and there is one more problem. There are four kind of problem under health and informatics, which will provide the computation capability for those NP hard problems. Because if you think about a simple protein folding or protein prediction, even the very lowest level of uh, they call it as a biotechnician, it is a proliferation of data by even with a smaller combination of drug to the protein, then that will proliferate a lot of data, and the processing also will become exponential, and also it needs unapproximated original data. So these are the reason why biotechnology problems which are targeting health and informatics trying to use quantum computers. And I know another professor, or to be precise, she is a researcher, so who is looking for people working in this domain. Bala, you can also connect with me. If your research is really interesting to that researcher, I will establish the connection. See, one thing here, I'm not the domain expert, but I know a lot of domain experts who are looking for quantum computing people. And if there is any FPGA people here, please connect with me. I will I have few requirements for FPGA people, quantum accelerators. Okay, Aryan Raj asked the question. I am from engineering physics. Okay, right. See, engineering physics people, huge demand in quantum technology. Already, you know, and there are very few colleges are offering engineering physics in India. So I know you, based on that knowledge, you have a good, bright future in this field. My recommendation is learn C programming and Julia instead of staying with the Python. See, everyone knows Python because I'm assuming already you know Python. Since you already know Python, this is particularly for Aryan, for engineering physics graduate. Since you already know Python, try to leverage the knowledge for building Julia and C++, because that is going to be used in HPC systems. Python may not give the necessary performance, but Julia and C++ will give that performance. So some of the most of the current NISC era systems, since quantum qubits are very less and then they are NISC era, the industry is moving towards HPC for quantum inspired solutions, and where we need good performance, these two languages are ideal candidate for building better simulators or optimization quantum machine learning problems running as a quantum inspired solution. That is specific for answer for Aryan. There is one more question. I am pursuing physics in my undergrad studies and have to plan pursue MS in quantum science. Yes, correct. That is the right path. I know three of my network. It is like they are my mentor. I am their mentor. I will ask physics question to them. They will ask programming question to me. They are in the same direction. One person is in Europe. Two are in US. They are doing the following the same method, but for MS they are not doing in India. They went to US, but now in India we have masters opportunity. IISc, IIST Trivandrum and Pune, ISER Pune, and there is one Punjab Technology University. They are offering masters in quantum. So you have a good in BITS Pilani also, I think, if I'm not wrong. And there are multiple ICERs started MS programs. Okay, you can follow that one. Then I have done masters in quantum optics. Very good. I am proficient in Wolfram Mathematica. Now willing to learn quantum computing. Guide me in this regard. See, already if you are in quantum optics, my recommendation is that move towards quantum hardware, because that is where the huge demand and skills also very scarce there. And quantum communication is the right path for you, like a quantum key distribution and photon splitting, those operations. And or else you can move to photonics quantum computing also. So that is where the computer architecture based knowledge will be helpful. So identify which is your best suitable area based on your current masters within quantum optics, whether it is suitable for communication or information processing by applying quantum information theory. So QAP or photonics, or QAP in photonics, or communication. If it comes to communication, obviously you should know key distribution. Under key distribution there are multiple schemes. Which one is going to help? Like that, if you proceed, that will be ideal for you. Anusha Sadri, can you quote one example of how quantum computing helps in R&D? We need to attach the domain, Anusha. General R&D quantum computing I don't recommend, because general R&D there are many classical solutions which are sufficient. But if you tell any domain, R&D in what? R&D in chemistry, R&D in material science, R&D in finance, something like that. If you add, I can tell you the correct example. I'm waiting for your domain answer. Wexter, what are the skills needed to be good quantum physicist? Obviously, quantum mechanics and optics, mathematics. Then little bit chemistry also, but particularly you should be very strong in standard model of fundamental particles, where the behavior of fundamental particles like boson, lepton, quarks, these things are all studied, and based on those behavior, the material science or any subatomic scale behaviors are built. So my I'm not a physicist, I'm a software engineer, but over a period of time I learned that for a physicist to become a quantum computing professional, they should have a strong knowledge in standard model of fundamental particle. Okay, Anusha, can you answer which domain you are referring for R&D? Sumit, please check and then let me know. I will answer
Yeah,
that.
sure.
Oh, there are a lot of questions.
Yeah, we have to
Oh, okay.
ask.
Then
So like,
Vexter question I answered for Hima Bindu, for an IT student who is working on quantum cryptography capstone project under a professor and have an upcoming internship session. What should I focus on?
Anusha was wanted to say about scope of electrical engineers in quantum computing field.
Which engineering?
Electrical engineering.
Electrical engineering. Okay, I will answer, Anusha. I will answer Hima question, then I will come back. So a student who is doing quantum cryptography capstone. Okay, if it is a quantum cryptography, I strongly recommend you should have a good grip on post quantum cryptography also. Why I am referring PQC? That is the actual implementation now. Even for example, if you see a lot of industries who are working on quantum cryptography, they have their PQC solution ready, a post quantum solution ready, post quantum cryptography, because that is what approved by NIST, National Institute of Science and Technology, and they have identified 4 PQC algorithm to build product, which means you have a authorized product guidance, and that is what industry is going to start using now. So you should have a good grip on post quantum cryptography, and whatever quantum cryptography you are doing, wait for another 2 to 3 years. When quantum computing maturing, your idea you can be built it. So for a internship in production house, you should have a strong PQC knowledge. Hope that helps. And now I will answer uh, Anusha question on electrical.
BK Hima. 5:17 p.m. Above it. Like I
Ah,
will read for you. So, should I
oh,
read?
okay, okay. Oh, sorry.
Yeah, for an IT student who is working on quantum cryptography capstone project under a professor and an upcoming internship season, what should I focus on
Yeah,
because
post
of
quantum
companies
cryptography.
campus for SDE roles?
Yeah. Hima, as I told you, focus on post quantum cryptography. Keep a strong understanding and your interest towards PQC. In during the interview or internship, you tell them that you want to build PQC solutions and keep quantum cryptography for another 2 to 3 years. When industry mature, I will use that quantum cryptography. Till that time, I will work on PQC. This is what the interviewer want to hear. Okay.
Even it also require a lot of software developing roles also. Like
Okay, for if it is the STE environment, as I told you, you should. I believe that all of you know Python, but also for cryptography, stay with C, C++, because that is where the performance will be achieved. And recently, the Rust language is coming with a good memory management for a secured execution. When it comes to security, Rust language is the first preference. So try to exploit Rust also. You know, right? There is a language called Rust. That memory management of Rust is the most secured memory management in any of the modern languages. So those cryptography who are working on the cryptography and information security projects, I recommend Rust language. Then Advaita, masters and PhD mandatory to get job in the field. What exactly would they? Okay, as of 2025, most of the industries are looking for masters and PhD only. That is the hard truth we cannot ignore. The reason is that quantum computing is the nascent stage. Obviously, the expectation is any resource who have been hired, we expect they have to do all work, starting from domain, physics, mathematics, then programming. Obviously, undergrad cannot handle that pressure, and their learning path or the steep learning curve, because it needs a steep learning curve. Considering all those things, the industry prefer masters and PhD. But an undergraduate who demonstrated the skills, they are also hired. Indeed, I myself mentored 2 undergraduates to enter into quantum computing professionals, starting from their first year itself, in undergrad first year itself. You realize, right? If you have an exceptional talent and then you have that capacity to showcase by connecting with the right people, participating in hackathon, building the next generation solution now itself. Those kind of exceptional demonstrations will help undergraduates to find entry into the field. Rajastri is asking question. Yes, Rajastri, go ahead.
I guess they are not allowed to like unmute. Maybe there's some
Okay.
setting.
Okay, let us.
Yeah,
Rajastri, ask the
just
question.
type in that chat box something.
Then Faith Girma, I'm undergraduate in the path of electromechanical engineering. Is this viable track to join quantum computing? Electromechanical domain, for example, if there is an optimization problem, Faith Girma, do you know any optimization problem like volume optimization, design optimization, topology optimization, which are based on FEA, finite element analytics, sorry, finite element analysis? Those kind of problems of electromechanical domain, they need quantum computing. So if you do some research on that particular class of problems which falls under either finite element analysis or any higher order differential equation problem, you can keep this way and go through that one. You can find a lot of problems. Based on that, enter into quantum computing. To solve that problem, instead of using classical, use quantum computer. That is the right path for you. Then Varun Rathore, I want to know more about the experimental opportunities quantum. What are the specific job roles in it? And what are the prerequisites for it? Okay. In the experimental opportunities, the quantum simulation is the good area, because I answered the same thing to before one question on biotechnology, health and information, and then there is one more question on material science. These two questions are the answer to those two questions, and your question will have a lot of overlap. So in the experimental opportunities, as I told you, simulation is the good one, because the simulation is using the properties of fundamental particles. See, when I say properties of fundamental particles, I am referring electron volt and mass and velocity and quantum numbers, and the what is called in the chemistry we put shells, right? Shells outside the nucleus. That all those things, those properties, simulating your system based on these properties cannot be done with classical system. That is where quantum systems are useful. So go to that level. Hope Arun that answered your question. Then comes Mihir. You mentioned about quantum machine learning and ML. I am an electronics engineer working on robotics automation and even learning ML at present. How quantum ML different from ML? And please mention the reference books list that you told. Yeah, book will be shared by Sumit in the group. I will give the complete list. Even I have, in the interest of lot of questions, books will be shared later by Sumit.
This question is really good. Like they wanted to know about QML and ML. Can you explain in layman so that they can understand how it is different?
And that is lot of questions. When there is a machine learning, then what is quantum machine learning? One good thing with ML, the say quantum ML is that, or one current as of 2025, quantum machine learning and is not implemented for real life problem. The reason is that most of the quantum machine learning problem needs minimum 40,000 qubits. One point I would like, quantum computers don't have memory. Yesterday also, when I deliver a session, I told this one, the attendees, oh my god, no memory, what are we going to do? That is the biggest shock when people are entering into quantum computing. There is no memory. If there is no memory, how you can see the training? Machine learning is depending on the training.
Right.
The training is obviously memory. Then how it is working? Even someone asked me, then how the QLSTM is working? Quantum long short term memory, because there is the word memory in that QLSTM, right? Suddenly, immediately I got the question, then what is about QLSTM? You mentioned there is no memory, then how there is a quantum long short term memory? So you should understand one thing, quantum systems are real-time system, or instance. At the instance, everything is populated into a density matrix, and the density matrix you use to solve the information, then close it. It is like at one instance, instantiate everything, process everything, measure and close. If your machine learning model can be done with the short lived infrastructure, you can target them. Now imagine that you are building a robotics or automation using a quantum machine learning. Assume that we have a smaller quantum computer fit into your robot, and this quantum computer doesn't have any memory. It will take the information from all the sensors at one instance, process them, make a decision, then it will dump. After that, it won't have any information. It will forget everything. If you want to make next decision, immediately you have to bring all the information at the instance, then do the processing. So that is the model. But classical machine learning, they have the advantage of persistent storage, RAM memory or virtual memory or high performance cache memory. They have a lot of memory, so they can pre-train, keep the pre-trained model for ready reckoner reference, then make a decision. This is the main difference between classical machine learning and quantum machine learning. So make sure that your model is an instance model, meaning that it will collect, encode, process, measure, close it. Okay, is it? Hope that answered your question, Mihir. Then Deepanshu.
Even sir, they can use this simulators also for now, because we don't have that.
Yeah, correct.
So if you want to practice Mihir, then maybe you can go for simulators. IBM provide their own simulators, run it for free, and just see how better it is, like as compared to classical.
Yes, that is what mostly we are using for the simulator, and that helps us to go to quantum inspired solutions.
Right.
Microsoft
Somebody asked,
Duo and
Sumit, are you?
Fujitsu
Yeah,
Digital
Fujitsu
Analyst
also.
and Toshiba SQBM. These are all
D-Wave also KG, like
D-Wave,
quantum nil,
D-Wave
quantum
Anywhere.
nil.
Because D-Wave Leap, they have released the software framework Leap, right? That helps you to build this kind of systems. Next question for you, Sumit.
Yeah, I can see that. Yeah.
Okay.
So can I will introduce myself also, because okay. So myself Sumit, I did my BTech from AKTU. Then I worked for Accenture as an associate software engineer. Then I have given GATE and came to IIT. Then I met KG, and KG like even as my background was from CSE, BTech CSE, so I was not aware about quantum computing. So in 2023, had a talk with KG, and he guided me like how his background was also from software, how he converted from software to quantum computing, and then now he's like leading. So similar was my experience, and then now I'm like this year only I'm like going to pass out, and already working for QNO Labs, and I guess somebody from India, they must be knowing about QNO Labs. They're working for QKD, providing encryption security to this particular world, and they have a lot of good initiative. So yeah, and feel free to drop messages from your chat. Okay. And this initiative I like started in last year in December, by reposting and giving the opportunities like this QuCode if you are active on LinkedIn. Then after that, I hosted the first cohort, like somewhere around 50 participants, because without any marketing and all, just going with the flow and learning, because wanted to do experiments. And then this cohort, somewhere around 500 participants we have received, and daily people are submit like 100 plus members are submitting Google Forms. So love to see people from all over the world, and happy learning, and just keep on following and go with the flow. Definitely you will land somewhere. Yeah.
Uh,
Yeah,
I
KG.
I appreciate your efforts, Sumit, because there are a lot of mentees I mentored. Many of them landed in a good job, and few of them started this kind of service-oriented initiative. I really appreciate, because you are doing. I know that you are doing for non-profit, and as a fellow country member and then industry people, even globally, you are targeting. It is a really great service. I appreciate. And as I told you, I will continue supporting your initiative, because this is the most important thing what we are helping the entry level.
Yeah, just wanted to highlight some new points which I figured out. One was like people think that the only students are involving here, but not like that, because I have data and I see always on LinkedIn, so I can see a lot of assistant professors, even the one who are doing postdoc, they are also interested in learning. So they are also learning with you. So never feel delayed that you are already late in somewhere or something like that, but they are also with you, and maybe their experience or their expertise can help you. Just learn with, just do marketing, do networking, and just do it. That's it. Yeah.
Yeah, yesterday I concluded one faculty development program. One faculty who retired 15 years earlier, he joined now.
See.
That professor really liked the session, and then he told, I want to contribute something to the younger generation. And Pratiksha asked the follow-up question, very much in quantum tech, especially QML. Industry experience AML must, no, not industry experience, but a strong classical machine learning. Underlying mathematics is very important. See, when it comes to machine learning, you should realize that machine learning is not Python programming, it is a mathematical modeling. Then Sujal Wadgave, is there any correlation between hardware and software domain of quantum computing? Or else if a person works in a hardware part, like on topological qubit research, he should not concern about software part. Sujal, your question is very apt, because those who are working in hardware, uh, they they have this doubt whether I should learn software also. In my humble opinion, no need. If you are hardware, you are already in a specific direction and scope. That scope is not going to increase. That will stay within your hardware testing, characterization, all those achievement, right? Please stay with the hardware. You don't worry about software. Okay, hope that answered your question. Then comes Abdullah. I have an electrical and electronics engineering background and exploring master programs in EU and Australia, interested in quantum simulation. Could you please share how someone with my background can examine it from a hardware and electronics angle? Okay, right. See, if you are exploring Australia, STU is the good destination. And if it is EU, DUDEF in Netherlands is the good destination. Okay, these are the things, but I'm not sure whether you are targeting them or any other universities, that whatever it is, but I know these two universities are doing a lot of things in this particular domain. So the hardware, you have to choose the type of qubit, whether it is superconducting or trapped ion or neutral atom or photonics. And even topology also, someone just now previous message, right, Sujal is on topological. My recommendation is, strong recommendation is, neutral atoms are gaining momentum, so focus on neutral atom based qubit and control systems necessary for neutral atom, because neutral atom control systems are hybrid model, because they use both microwave as well as laser. Because of this hybrid requirement for control systems and qubit operations, readout, integration, all those things involve best of both technology. You have a good opportunity. If you start with the neutral atom, you can move to superconducting or photonics. See, the trapped ion and photonics, they use laser, superconducting using microwave, but neutral atom using both microwave as well as laser. Hope that answers your question.
KG, we have a lot of doubts and we still have some
Oh,
10 to
okay, right.
11 minutes.
Okay,
Maybe
right.
I'm not sure meeting will end or not. Let's see, like we can cover it up, like, or
I
maybe
will
we
try
can
to
take
complete
next.
it.
Yeah,
Okay, maybe
Yeah.
that's
we
why
can
I
avoid
kept
some,
only one slide.
come again.
That's why I kept only one slide.
Okay, yeah.
How to start research in quantum physics and quantum computing from UG level and BTech computer science in first year students. So first thing is, you have to choose any three vertical: quantum optimization, simulation, quantum machine learning. These are the three things what is easy for you to start with, because being a first year student, you cannot go wider. So choose any one of these list, note it down: quantum optimization, quantum simulation, quantum machine learning. if it is software. If you are going to hardware, that is a different. I think you are not planning hardware because you are a computer science student. So considering that one, choose any one of this one and then identify the domain, either finance or biotechnology or computational chemistry or mechanical problems. Connect with a mechanical engineer who wants to do finite element analysis based problems like design optimization, volume optimization. I connect with some domain people, but choose any one of these three vertical. Hope that answers your question, Rajratan. Rajratan, okay, right. Then Sajia Pari, I'm also a physics student. It is beneficial quantum computing and quantum information learning. I recommend start with quantum information because quantum information theory is easy to comprehend for a physics students compared to quantum computing, because quantum computing needs software programming skill, but information theory, QAP, or quantum information processing, that is easy to connect with the physics concept, quantum mechanics concept. If you start from postulates of quantum and go to the various aspects of quantum mechanics and how the superposition, entanglement, and interference and other quantum behavior are used to build the computing component, that is easy path. So go to quantum information processing, from there come to quantum computing. Okay, hope that is the correct path for you, for your interest. Then Varun asked another question. I am in a quantum communication, quantum teleportation part. Can you please help some professor? Yeah, sure, Varun. You connect, you get my number from Sumit and then connect with me. I will help you with the that particular resource person. Aryan asked the question. I am doing C++. Yeah, good. Thanks a lot. Because C++ is much better. If you are following C++, start with a framework called QLACS. QULACS. That is what good starting framework. QLACS. That QLACS is wonderful C++ based simulator. Hope Aryan noted down, right? QLACS. Then Advaita, is there any chance to, oh, sorry, is there any chance to get a job as a fresher in electronics and computer engineering in the domain of quantum computing? Yes, okay, right. Advaita, as I told you, remember, I mentored even first year undergraduate engineering student to find a quantum computing job when they come fourth year. But I started mentoring from their first year. So it will take some time, minimum 12 months to 18 months to get a grip on what problem you can tackle. So if you have that persistency to work on a quantum computing problem for 12 months to 18 months and build something and demonstrate that in the form of network, into your network, either through LinkedIn or hackathon or publishing a paper, that will help you to land a job in your third year or fourth year. But first 2 years or first 1.5 year, you should stay within quantum computing, should not get confused, or many people use, oh, there is no job, let us go to full stack development or DevOps or cloud computing. If you, without distraction, you have to stay in the quantum computing for at least 12 to 18 months. If you have that patience and persistency, I recommend you can do anything substantial to demonstrate your skill. Okay, and obviously all this framework you should know: Qiskit, Pennyline, Circ, D-Wave, Leap, or Forest from Rigetti, Amazon Bracket, and Q-Tip, QLACS, QEra, Blackhead. All those things you have to explore. You cannot stay with only Qiskit. That won't work. It is the hybrid model only. Even I'm building now solutions. I will start with Qiskit. For some functionality, I will take from Pennyline. For some functionality, I will go back to a separate library. So it is not, one framework is not suitable to build a end-to-end solution. Then Srashti Mittal, I have completed my BTech in aerospace engineering. I would be grateful if you could briefly explain the scope of quantum computing. Very nice. Srashti Mittal, if you explore internet, there are two challenges, quantum computing challenges. 2019 Boeing, 2021 Airbus. These two organizations conducted quantum computing challenges. Now think about, these two companies are topmost in their domain. Both conducted quantum computing challenge. Now we understood how aerospace is betting on quantum technology. So first I recommend go to internet, find out what are those two challenges, and these two challenges had four problems. So there are four problems in aerospace which can be solved using quantum computing. So I'm not explaining all those 8 here, but I know very well because I participated in both challenges. So I recommend you go there, explore that one. For further information, connect with me or Sumit, we will help you. Then Dipanshu, I'm doing BS in specialization physics and will choose quantum as a specialization. Should I go for MS or PhD? PhD. Hope that answered your question, Dipanshu. Then Vexter, and again question, final year student in physics. I'm doing final project on quantum optics and planning to pursue MSc quantum tech or related. Is it good idea to go to industry for a year? It is, see, if you are in quantum optics and MSc and going to sorry, your final year student in UG, right? Better you see, if you are in BSc and MSc, I don't recommend you to stop in between. Complete BSc, MSc, then come back to then come to industry. Because that will give you, because particularly this one, if you go to industry, you will lose the continuity in the research. Because if you are doing something on quantum optics, because someone earlier, there is a quantum optics person also, right? You can connect with them and understand. It is very difficult to keep the knowledge if you come in between industry, because industry will demand huge, there means a lot of distraction. You may lose, or you may not become, how to say, you will become, your hands-on experience will get reduced if you come to industry. So if you are in undergrad now and continue MSc, complete the research, then come to industry. Then comes, are there any opportunities in post quantum cryptography? Sumit is the right person to answer.
Yeah, there are a lot of opportunities, and the first company which I mentioned, which in India, which is working. If you're from India, let me see. Yeah, even not if it's not India, then there are other companies also. So which are working on quantum. Like QKD is the one. There are three things in cryptography basically. How cryptography we divide it. The first one is quantum key distribution. Second is quantum random number generator. Means like random, because all the things are working this RSA and all the which we like people are trying to break. Then third one is PQC, as KG already mentioned. So there are a lot of opportunities, and like this is the one which is working on. Rest things need hardware. Like if you see this, there's a difference. Like I suppose if you want to learn execute machine learning programs, then you need a particular, as he mentioned, something 60,000, 40,000 qubits you need. But still in India, like it's something like we are this QPI somewhere around 25 qubits they have developed. Maybe IBM is also working on. So to achieve, maybe it will take some year. But for this particular quantum cryptography, we already had this solution. You
Yeah.
can search about ADOS machine and Hudos machine of QNO Labs, and even other countries also have this security. So there are a lot of, this is the more practical, and you can easily and suggest a roadmap or a tech stack. Go with the learning of basics, like of just there's a concept of quantum optics, as somebody already asked. Quantum communication will also play an important role while learning quantum cryptography. If you want to land in QKD part, to understand the hardware part or the experiment part, you need to understand how optimization this particular communication part is working on, like Alice Bob and then BB84. These things you have to, ECART 91. These algorithm you should, all the protocol you should know when you're going to enter this field. Yeah, KG.
Yeah, great, good answer. And I strongly recommend go to QNU Labs website and
Yeah,
understand their product, Armos, and they have the chat also. Try to understand their existing product. That is really a good demonstration of quantum communication. And QNU Labs website is one thing what usually I recommend. But since Sumit is here, I'm just keeping quiet. Okay, right.
okay, fine. Yeah.
And Naveen,
Then
there are a lot of questions. Let me first word.
yeah.
I have completed my UG in BE with cybersecurity, and while navigating further for my career quantum computing, does it mandatory for me to go with masters? So if you are already an engineer with a STEM background, computer science and cybersecurity, see, it is affordability. If you can afford, and then your family can afford your master's degree education, I recommend go to masters if you want to stay in quantum computing. But if there is a necessity to get into a job and then gain, you have to come. If you are staying in classical, I would recommend come to industry, then go to master. But if you are planning to pursue quantum computing, I strongly recommend continue with the master. The reason is that quantum computing industry is not matured. Even if you come now, there are no many companies to offer you job. Even see, I will tell my model. I will always hire 3 months unpaid. Why? It is not because the payment, because it is you have to identify the right person. For that we'll need 3 months. So 3 months we cannot pay, and after 3 months we will realize no, this person not suitable. You got the point, right? Most of the companies are following either paper publication work or unpaid internship. That is how the current startups are exploring the resources. Considering that one, if you come to industry now, you cannot find a good paying job in quantum technology if you are a fresher and you don't have a strong network. Considering all those things, I recommend go to masters. Then there is a question from Varun. I'm doing quantum computing for 2 to 3 years experience and more exposure to field before applying masters and PhD. So directive higher studies. Yeah, you should continue directly go to higher studies. Again, the same reason what I told for. Then Harshit, second year BTech in AI. How to start QML and go for uh, research it. So first understand all AIML classical model with mathematically. That is the first thing, because AIML means most of the most, not only AIML student, computer science students are using machine learning, mechanical students, electrical students. If you take engineering, all branches of engineering are doing machine learning in their final year project. Recently I went for a project evaluation. I see everyone is doing machine learning. They are not AIML student. So what is the difference AIML student to demonstrate? The main thing, how you are demonstrating your capacity by understanding the underlying mathematical model. Correct. If you strong understanding of the mathematical of AI model, AIML model, try to map them to the quantum machine learning and underlying mathematics, which is based on complex number, linear algebra, and matrix composition, decomposition, all those things by complex. So always map your knowledge with mathematical model, then come. That's what the main differentiation between AIML student and normal software engineers. Any scope for condensed matter physics and biophysics? See, CMP, what you are asking is, it is there, but I don't have knowledge on that one. I have to ask my mentor who is into um, particle physics, and I don't have correct answer, so I'm sorry, because this is something very special thing, and without proper knowledge I can't misguide you, so I don't know. But connect with me, I will find out. One of my mentor is from nuclear physics. I will ask from him and then tell you. Where can I learn build PQC solutions? For PQC, NIST has one website. They NIST website is a good starting point to understand what are the approved 4 models. Then there is a website called Algorithm Zoo, Quantum Algorithm Zoo. That is the website. There you can find out the underlying quantum algorithms which are supporting the NIST selected model. After identifying those models, you will come to know what are the mathematical models supporting that algorithm. Then you have to start from any linear algebra based YouTube channel like Gilbert Strong or 3 blue 1 brown. Those are all the good starting point for PQC. For PQC, there are no lot of resources in my observation. There are very.
Maybe, yeah, he can follow that Scott Anderson, that guy. So just follow him. Just watch some videos which he already shared. Then he can get an idea. Then maybe he can go to NIST or Die Hard, and there's one more ECT. So these tests you can learn, and then yeah.
Okay. Thanks, Sumit. Thanks for adding. Okay.
I have
Then Lakshita asked the question. I'm BTech final year student doing course from QPI. I'm beginner. Kindly give me a roadmap. Working on my math. I'm weak in it. Kindly give me a roadmap. Okay, if you are in math, I will recommend you to start with Veritasium. There is a YouTube channel called by Veritasium. 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 That Veritasium YouTube channel explains the mathematical concepts with the historical and application. They won't directly jump into the mathematical concept. They will explain the history and theory and application. After that, you can learn from 3 blue 1 brown. So that method, you will get a good grip on mathematics. Also, I will recommend this book, 17 equations that changed the world. That will give you a good interest on mathematics. Then you can start learning mathematical concepts. After learning this foundation, read a book by George S. Woody. The book title is Essential Mathematics for Quantum Computing. Then learn other book, Quantum Computing for Everyone by Chris Benhart. These are all the books you have to learn to upskill yourself and then get a good mathematical intuition towards quantum computing concepts. Lakshit Sharma. Then that day I answered the question for Lakshit Sharma. Rakshant Jagan. Which challenges do you think quantum AI stops to face in finding the client, finding the paying customer? That is the biggest challenge. It is not technical. See, I am an entrepreneur in this industry for 1 year. My company is 1 year old, right? The biggest thing is finding paying customer. So that is the biggest challenge. So it is not technical. Technically, you can hire some expert or a good person, get the solution built. Even I have my own website called demo.QuantumG, where you can go and experiment various algorithms. But if it is free, okay, there are people to explore. But if I ask them for a potential customer, would you like to subscribe? They are not ready to subscribe. That is the biggest challenge. And if I go for foreign customers, they want something working piece. The working piece need a lot of computing cost, meaning that if I provision a AWS cloud or AWS M4 systems, that AWS systems will charge, right? So that is the biggest challenge, finding paying customer. It is not a question, I know, but I have to give you the realistic picture. That's why I'm told you. Then Pratik Shitol, I'm staff engineering and want to know if any portal where corporate and posting with their interest in POCs with the quantum tech and looking for venturing out. See, if that is the case, go to the Quantum Insider website. The Quantum Insider website has one more link for, I think it is called get access or premium access. If you go there, that will display another dashboard. In that dashboard, you can find out funding, government projects, but it is government projects only from US, but it will give global funding or organization and the various services, ecosystem, everything. So in my observation, the Quantum Insider, that is a good source to start. Then Anjali, sir, maximum how much qubit we can simulate using simulator? It depends on your local system. The number of qubits minus 8, that number of qubits. For example, if you have 16 GB RAM, you can plan a maximum 8 qubit. If you have 32 qubit, you can plan up to 21 qubit. So that is one reason usually we will go for HP cloud systems. If you provision a cloud system, you will have a good memory, right? 128 GB RAM also you can provision, or server, Xeon server, or if your college or your organization has a data center, explore that option. Or else go for paid Google Colab. Paid Google Colab will give you 16 GB. You can go up to 8 or 10 qubit. Hope that answered your question. Anjali, another question. I am a beginner on material simulation using quantum computing. Please guide me some how to start. As I already, I think, answered that one. You should start with the standard model of fundamental particles. That is where The Because normal simulation, if we start with the chemical properties or physical properties, they will still at the atomic scale or above atomic scale. But quantum simulation should go subatomic scale by simulating the properties of fundamental particles. Like quantum numbers is one example. Right, those who studied quantum numbers, there are four quantum numbers: principal, azimuthal, and there are two I'm not able to recall. So there is a formula, the Pauli exclusion theorem, which tells no electron has same quantum numbers, the four combination of quantum numbers. None of the electrons, see, each electron can be uniquely identify these four quantum numbers. So you have to go to that level for your simulation. Sumit, how many minutes we are having?
We already crossed
Yeah.
the time. We can cover just in 5 minutes and then we can
Okay,
end.
right. Please stop the questions. No more questions. We will stop.
Yeah,
Answer all the questions whatever you posted. Aryan question: what is quantum machine learning? First one is mathematics. Second one is Python programming. Then a strong understanding of the classical machine learning. Is this enough, Aryan? And also, you should identify the good domain. Okay, what are the different domains present in quantum hardware? Uh, The five quantum computers: superconducting, ion trap, photonics, neutral atom, topological, and quantum annealer. This is the broader domain. But within this domain, there are control systems, optics, communication, cooling system, cryogenic, data encoding, shielding, radiation shielding, testing and characterization. There are a lot of things in the quantum hardware. That's where quantum hardware has a wider scope compared to software. Is there current research exploring quantum enhanced reinforcement learning for robotics? There is one paper yesterday morning I saw. When I search for something different, I come across a paper on particularly this reinforcement learning for quantum inspired, not quantum enhanced. Yeah, maybe close overlap. It is there. Quantum. You search for quantum inspired reinforcement learning. Then Yogesh Jankit, quantum information, quantum computing PhD. I want to uh, and this question will become a kind of biased. See, I cannot recommend this is the best unit, but I will tell you which colleges are offering this masters and PhD.
right. Mhm.
IISc, ISER Pune, and IIST Trivandrum, and TCG Crust, and IIIT Hyderabad, and
Even IIT Jodhpur plus this.
IIT Jodhpur. That I don't know, but I
There's
know
one
there
more
is.
IIT Madras also, like some, but they have some specific projects like machine learning, quantum machine learning. So you have to like there's one IDRP department. Winter opening will be there like this upcoming winter, so you can check that out.
Okay, right. I
Yeah.
think Mihir posted. Thanks, Mihir. Thanks for the feedback. Then Harshit, how to get internship in QML? What interest you are looking? See, for example, I'm hiring QML interns. So send your resume to me. I will check that one. But as I told you earlier, you should ready to demonstrate your skills for 3 months. Either publish a paper with my team on no financial commitment, or else work as a 3 months unpaid interns. Then we will decide. I will tell you. I will give you feedback. Then I will tell you what working. And defense, there are a lot of opportunity in defense, because I am taking classes for defense people also. I know what are the things are going on. I cannot reveal everything in the public forum, but I can confidently promise you there are a lot of opportunity. DRDO is, if you are joined with your approach your professor, ask them to apply a funding for DRDO project on quantum technology, you will get immediately. Then you will understand that one. Yeah, Sumit, there is another.
We already have WhatsApp channel. That's not a group, but WhatsApp channel for discussion. We are working on Telegram because there's a lot of good features on Telegram. So that's even I will share the link of our Telegram group. Already 500 plus members are already there, and there's some WhatsApp. There's some limitation and we have like there a lot of good features. So that's why I switched from WhatsApp to Telegram. So I will share the link of that. Yeah.
And Pradiksha asked the question. So that is why, Pradiksha, we are building only proof of concept or prototyping. We are not building a real working system as of now. All our projects, even to showcase our client, we will clearly tell we cannot build a production quality system. We will build only prototyping or proof of concept. You can file patent for this one. Keep it as a futuristic solution. But hands-on experience you can gain with the less number of qubits. There are simulators, right? If you go
Yeah,
for
even
qubit
I
simulators,
want to answer this question.
yeah,
I
please.
also did my master's thesis from this same, like image classification used in QCNN, quantum convolution neural network. So for that, like for to show our thesis that is correct or not, we use simulators. So that's the only option. And as KG mentioned, we have like a limitation on this device. Like if you want to run this training part, that's very difficult because we don't have that much good CPUs. If we need GPU, then we have to pay for it. Google Colab or Kaggle will provide you for maybe for a few hours or just few hours only. So rest you have to pay. So that's why, as KG mentioned, we need to wait for that. For before that, we can use simulators and show our results. Yeah, over to you.
I recommend connect with your college. Through your college, apply for credit from AWS or IBM.
Yeah.
That is much better way. They will give you the educational credits that you can use for running your simulator, because IBM is charging $98 per minute. Remember that. After, if you cross 10 minutes monthly
Yeah,
budget,
that's fine.
be careful. Books and all, yes, Lakshit, we will share. And can we use Azure Cloud? Yeah. Azure Quantum has everything. Azure Cloud is also having what is called GPU machines, and Azure Quantum has lot of systems. IonQ systems are available in Azure Quantum, and Microsoft QIO, what I mentioned as a production quality system for quantum inspired, that is also available. So you can explore Azure also. Yeah, that's it.
Yeah. So there's a feedback form. So you feel free
Okay, in
to.
the interest of time, we will stop here. Please
Yeah,
connect with me through Sumit. We will continue the support.
yeah, drop an email or just I will just share the credentials and everything. So yeah. So and must fill the feedback form so that we can improve. Like we need your suggestion from your side so that if something we are missing and we can improve on it. Yeah. Rest doubts like we already like.
And Sumit, also with your permission, can you tell them about the quantum G and that also?
Yeah, sure. So
Okay.
QuantumG is like a initiative by KG, and like it's working on providing the educational part also. Like suppose if you want to, if so, our courses is like free of cost, and like usually there's a mentality if somebody is providing something for free, so people usually don't take that much things seriously. So KG has his own particular platform, like for different field. Like suppose if you are from physics background, you don't know about CSE part, so he will help you to understand, and he has our own team, the one who are already in R&D. These guys are working, and they will be teaching you live. And though for more details, you can KG, can you show a website little? If, then it will be good
No,
for.
no, okay, this is www.quantumg.com.
Yeah, just and do follow the page of like on if you want to see the recent updates, you can follow KG's LinkedIn page, that is Quantum Computing Research Limited. So see R&D in quantum technology, and he also provides, as he mentioned, internship opportunities also, and you will have, as he mentioned, you will have also opportunity to write paper with him. So
Yeah,
that is the really great thing, like while doing a bachelor's or master's, if you have paper that shows like yeah you have R&D like hands-on everything with you.
thanks a lot.